and OSU-Cascades have come together to provide a great experience to end the day's activities, and we thank you for joining us. We'd also like to give a shout out to Connect Central Oregon, whose unique internship program and digital expertise helped us bring the production together tonight for this evening, so thank you very much. Before we get started, I'd like to introduce you all to Jack Barth, OSU Marine Studies Initiative Executive Director. Jack, take us away.
Great, thank you, Nathan. Welcome everyone to our celebration of World Oceans Day, held each June 8th since this day was declared by the United Nations to focus attention on our ocean. And I'm really excited that we're about to start the UN Decade of the Ocean Science for Sustainable Development from 2021 to 2030. What a great time to have a focus on our oceans. So on this globe next to me, you can see it truly is an ocean planet. The ocean supports life on our planet, supplies oxygen, provides food. 90% of goods are shipped by ocean vessels, and our coasts support thriving coastal communities. The oceans play a key role in our climate. The oceans are literally taking the heat for us, absorbing both heat and carbon dioxide from the atmosphere. And as we know so well in Oregon, it drives our weather. But the ocean and coasts are more than that. Salt water is in our blood. We are inspired by the view from the shore. The ocean is in our music, our stories, and our art. So this evening, we celebrate the ocean through films, photos, storytelling, music. Our celebration comes at a time when we must not only remind ourselves to take care of our ocean planet, but also take care of each other and to reaffirm our commitment to equal opportunity and justice for all. So in celebration of World Oceans Day, enjoy the videos and ocean trivia, and I'll see you again for our panel after the Heck at a Bank film screening. And I'll hand it back over to Nathan.
All right, Jack, thank you very much. So tonight, just to go into a little bit more specifics, we're going to be showing the short film Sense of Place, followed up by the film Heck at a Bank, Oregon's Hidden Wonder. And we're going to mix some trivia in there along the way with the special group that contributed tonight. Afterwards, we're going to start a question and answer panel with a number of folks related to the film. And then to finish off the event, to kind of add a little bit of an artistic piece to it as well, we've got a reading of The Rainbow Fish, written by Marcus Feister, and then wrapping up with a musical composition, Currents, by OSU's own Dr. Dana Reason, to finish off the evening. But before we get going, we're going to talk a little bit about audience participation. Those of you that have joined us before, you can definitely do questions in the YouTube feed and the Facebook feeds, but we also use Mentimeter.com if you want to put some questions in. It's very, very, very easy. We basically have you go into menti.com, so www.menti.com. You can go in through a website, you can go in through an app that you can find in your participating respective app stores, and the event code, it's really as easy as entering the 6-digit code in. Tonight's code is going to be 452729. Again, that's 452729. And you're going to be able to ask questions. You can start submitting them now. You can wait to our question and answer panel. And we're going to be able to use that for the question and answer piece. Additionally, because we have so many participants tonight, if you would like to submit some questions to us, marinestudies@oregonstate.edu. Again, that's marinestudies@oregonstate.edu. You can submit some questions, and we're going to try to answer as many of those as possibly can, because we're sure you have them. So let's go ahead and without further ado, get started with the presentation of Sense of Place.
I always found myself lost to the ocean. Every time I stand at the beach, its beautiful waves seem to whisper to me, giving me calmness, serenity, making me forget reality. I grew up near a beautiful beach in a fishing community in Malaysia, and because of that, I got to eat fresh fish almost every day. Every weekend, I would go to the beach to watch the sunset, to watch fishermen on their boats going back home. It made me realize how important the ocean is to me. I always feel a connection to the ocean no matter where I go. Even when I'm thousands of miles away from Malaysia, The ocean connects me to the place I call home. But the ocean has changed over the years. Whether I'm in Malaysia or Oregon, I hear about the same problems: ocean acidification, pollution, and habitat destruction. This always makes me sad to know that my childhood memory is not going to be the same anymore.
So when we think about changes, you have to think about the coastal ocean. It's an evolved system that's used to certain patterns and rhythms. And that starts in the spring when the upwelling winds begin. You get plankton growth, and that lasts sometime through September, October. That's the growing season. So what we're looking for are changes to that rhythm, whether you're lengthening that growing season, or you're shortening it, or you're getting more upwelling or less, or if you're getting this warm upper layer that kind of caps things off.
If we're going to tackle all of the changes that are happening out in the ocean, spaces and institutions such as the reserves are going to be critical. And again, that collaboration between the scientific community and the people who help facilitate their science, that's crucial too. I decided to join the Marine Reserves volunteer program because I wanted to be a part of the collaboration between the natural resource communities here on the coast and the science that they're doing in our new marine reserves. I think in order to protect this place, that has to happen.
I started volunteering with the Hook and Line because it gave me a chance to reconnect or connect with the ocean. And when we're out there, we're seeing what is happening to our ocean. We're seeing species move from one area to another, and species in decline. And we're seeing new species come in. The future of the ocean and the future of the coast is nothing for me to worry about because it's going to survive. It's always been here, it will always be here. But the overriding concern is, what about the people? What's going to happen to them?
The Marine Reserves volunteer program gives me a sense of optimism. I feel a little bit more connected to the surroundings through the program because a lot of the volunteer opportunities occur in places that aren't accessible anymore.
It is amazing what education does, because now they're learning something new that they probably never ever thought about. And when they learn about that, they get that connection and they develop this love. And that is when they're going to start doing things.
No matter where you are, there is lots of opportunity to contribute to the solution. I'm optimistic that these kinds of volunteer programs will help us to get on a more sustainable path into the future.
All right, so it's a great start for tonight's evening. As promised, let's roll into our first round of trivia brought to you by OSU's Ocean 11 Marine Club. So fun fact for you, the club's 11 in the name comes from the fact that the club is represented by and open to all students from all 11 OSU colleges on the Corvallis campus. So it's kind of a fun little fun fact for everybody. So let's go ahead and get to our trivia right now. Some of you saw these rotate in through the sponsorship slides in the beginning, but we're going to go through them for everybody that came to us a little bit late. First question, you're going to do these on your own, and we're going to go through the answers here in a second. What percent of the oxygen in the atmosphere is produced by marine plants? Greater than 50%, 10%, 25%, or 100%? So jot your answers down. It's self-scoring. We trust you. Let's see how you do. Next question. This bone in the inner ear of fish contains rings. When cut open and counted, the rings tell us the fish's age. What is this bone called? And I practiced these, so hopefully I got these right. Ichthyost, stapes, malleus major, otolith. I'm going to let Tom grade me on that later on when we do the Q&A. All right, next question. I started early, took my dog, and visited the sea is the opening line of the famous poem By the Sea, written by Rachel Carson, John Muir, Emily Dickinson, Walt Whitman. The ocean is becoming more acidic because it absorbs carbon dioxide from the atmosphere, which is increasing, dumping acidic plastics, hypoxia reducing oxygen levels, sunscreen adding oxybenzone and octazonate into the water. I think I butchered that one. Which of those four? All right, get those answers together. And going first, greater than 50%. Answer to number one. Letter D. That is the name of the bone in the inner ear of the fish. Emily Dickinson, C. And for the fourth one, it absorbs carbon dioxide from the atmosphere, which is increasing. So keep those scores down. We're going to do round two of trivia here after we do the next video. But again, I want to thank Ocean 11 for participating and providing those questions for us tonight. Thanks for playing. And again, let's go ahead and transition to our next film, Hecate Bank, Oregon's Hidden Wonder.
Well, my name is Bill Piercy. I've been at OSU since 1960. I was one of the 5 founding members of the Department of Oceanography back then. And now I guess I'm a Professor Emeritus in CEOAS, College Earth, Ocean and Atmospheric Sciences. And most of my research has been on what we call marine nekton, fishes in the ocean, but also squid and shrimp and other things like that. So I've had a really good time here. Great career and a lot of fun.
The rugged coastline near Cape Perpetua is known for its spectacular scenery and abundant wildlife. But the landscape that has fascinated scientist Bill Piercy for most of his career lies below the water. 35 miles offshore from Cape Perpetua, there is a deepwater bank known as Hecate Bank.
You wouldn't see it, just looking out over the blue expanse. It's one of the most productive areas on the coast. It's a hotspot for biological productivity. We talk about our successful fisheries in Oregon. Hecate Bank is the place.
So it's an extremely productive area because of these two things: unique position and the currents coming from the north during the summertime, accelerating upwelling. So it's a very productive area.
Hecate Bank has become one of the most studied features off of the Oregon coast. But that wasn't always the case. In the 1980s, Bill Piercy became one of the first scientists to get an up-close look at the underwater world of this structure.
And in 1987 and 88, I was privileged to make some of the first submersible dives off Hecate Bank. And it was amazing. It was truly amazing.
Brown above. Yeah, quite here they come into view pretty well.
There was this huge concentration of fish, very abundant, and high diversity. And rocky pinnacles on top of that bank were just amazing habitats for big, what we call macroinvertebrates, things like sponges and crinoids and basket stars just blanketed these rocks. Big things like that.
The submerged structure, Hecate Bank, is unique on the West Coast. It transforms the waters around it, driving biological productivity and making nearby habitats thrive. Its effects are felt 35 miles away on the shore, and and even deep in the coastal forests. It draws birds and mammals from across the globe to its thriving waters. You're about to learn the science behind what makes Hecate Bank tick. A unique blend of geology, oceanography, and biology that has shaped a natural wonder unlike anything else along Oregon's coast. The productivity of Hecate Bank is driven by its geology. And to understand what makes it so special, you must first learn about the forces that created the uplifted structure of the bank.
So the way the ocean works is you get the coast, and the bottom drops off kind of slowly, and then it hits the continental shelf break and it just plummets down to the abyss. And the width of that is called the continental shelf. And what Hecate Bank does is it widens that continental shelf to over double the width. So it kind of sticks out into the ocean from the shore.
The offshore area of the Pacific Northwest from Cape Mendocino up to Vancouver Island is a subduction zone. And that essentially means that the Juan de Fuca plate is diving underneath North America. North America is acting like a snow shovel and just peeling all the sediment off the incoming plate and just kind of, just like a snow shovel, just kind of smushing it into a disorganized pile. It's a big attractant for rockfish because they're just rocks everywhere. So it's a very popular spot for rockfish that are looking for cover. And there's sort of a halo around that of where the juvenile rockfish live. But it's also, directly abuts big sandy areas where flatfish and other sort of sand-loving, biota live. And so it's kind of it's a very rich area that sort of has it all.
Geology is the first key to the puzzle of Hecate Bank's productivity. But another major factor is the oceanography, the way the movement of the currents, upwelling, and waves interact with the physical structures. The first documented mention of the bank came from Bruno Heceta, a Spanish explorer that gave his name to the structure. Heceta Bank, or Hecate Bank, as many fishermen and scientists now call it, was first described by the captain for the noticeable change in the watercolor. This was likely due to the high levels of chlorophyll, which jumpstarts the whole food chain.
The color of the ocean is very obvious that this is an area that has more plankton. If you're in a commercial airline flying down the coast, you're gonna see it. We fly satellites that can measure the actual chlorophyll, and there's a big pool sitting over the bank. It's Hecate Bank and Stonewall Bank. We call that the Hecate Bank Stonewall Complex. And it's that area where you see high amounts of chlorophyll in the water from phytoplankton blooming. We see a really productive upper ocean where fishermen can go out and catch fish. So it's this special area. And the reason it is special is because of that underwater topography and the way the currents interact with it. But what's amazing is the amount of structure that's there, both in the vertical, different layers, warm waters, cold waters, productive waters, not so productive. And then further, there's this set of currents that are being swept around the banks, and it's just a swirling, active area. So we know a lot about upwelling, how the wind blows and it brings up cold water from below and those nutrients. And what the bank does is it restructures that, and it actually enhances that upwelling in that area. So over the bank, we know there's a bigger area of colder water, a bigger area of nutrients, and a bigger place for plankton blooms. As that southward flow comes barreling down the coast, it encounters this obstacle, which is the bank. And oceanic flows don't like to go over things because the water's layered, and it just takes too much energy or momentum to go over something. So what it does is it goes around the outside, and the bank presents that obstacle. Because the bank is wider and the flow goes around it, it actually amplifies the upwelling. So there's more cold water in a bigger area over the bank. And you can see in these satellite images, there's a big cold part over the bank. And that cold water's come up from below and it's full of nutrients. And it's just the perfect recipe for a phytoplankton bloom. And it happens right over the bank there. And you can see it spreading out from the coast. It goes out 40, 50 miles and it squirts offshore with all this rich plankton mass. So in this image, we're using bright reds to indicate where chlorophyll is high. With your naked eye from the coast, what you'd see is this green-brown water, this sort of soup. That's all good stuff. This is the plankton that's at the base of the food web. So that same wide area temperature is covered with plankton. It's a big, wide area. You can see in the bright reds here, it swirls around the bank. In fact, some of that water gets shot offshore and is providing nutrition or plankton to the offshore communities.
And that's the water that's so rich in nutrients that starts the food chain. First with phytoplankton, little plants that need the nutrients and carbon dioxide, and they grow and they get bigger. And then you have little zooplankton, things like copepods, euphausids that eat these little plants. And then they're the fodder for bigger things like little fishes and like anchovy, for example, and sardine, and little rockfishes and juvenile fish of all kinds. And those then are eaten by the bigger predators like salmon, bigger rockfish, mackerel, other species that are common off Hecate Bank.
One of the most fascinating effects that Hecate Bank has on the food web is how it interacts with offshore deep ocean species. In these cross-section charts, you can see concentrations of different sizes of fishes near the bank. Because of this interaction, it creates a virtual buffet of forage fishes for predators of all types.
So here you can see in the top panel at low frequency, near the surface, there's forage fishes like anchovies, herring, sand lance that are close to the surface, and they're usually found just offshore of a front off of Hecate Bank. This shows the animals that are smaller, like Quirilla euphausids, little shrimp-like animals that are about an inch or so long, very abundant off the Oregon coast, in offshore waters. And these animals migrate vertically. They go down in the daytime, come up at night. And when this happens, a lot of times they're wafted inshore, and they get trapped behind Hecate Bank here. They're very, very vulnerable to any kind of predators in here. And besides the euphausids, myctophids or lanternfish are often found in big concentrations right off Hecate Bank.
The oceanography and the geology of Hecate Bank are the engines that drive the biological productivity and amazing diversity of the region. The bank attracts a wide range of species, which in turn attracts the scientists who study them.
Hecate Bank being a rocky, deep-water rocky bank that extends up from 500 meters up to 70 meters, it's within the depth range of many important commercial species and non-commercial species of fish and invertebrates along our coast. Again, you kind of have this change of habitat types as you go from the middle of the continental shelf up onto the eastern flank of the bank and then over the top of this rugged ridge that forms the top of the bank and then down through these boulder and cobble habitats. And as you go from one habitat to the next, you see major shifts in the fish communities.
And when you actually look at some of the footage that the remotely operated vehicles and submarines bring in, you see that thick green water, and you see just thousands of baby rockfish and other organisms there. And one of the things that we discovered working with folks on the coast there is that those fish are a really important food source for a lot of predators, including other rockfish and salmon. So when the Chinook salmon come in, on their way to the rivers, they are chowing down on those juvenile rockfish. And you can see that if you go to the cleaning stations and open the stomachs of the fish as they're being cleaned. And so what that means is that high productivity on the bank is getting transferred all the way up into the Coast Range. The Chinook are also going south all the way down into California and taking those nutrients that they're picking up off the bank down into the Klamath and the Sacramento and so on. So there's this connectivity that happens within Oregon, but it actually extends all the way down the coast.
So the marine birds are a good indicator that there's food available in that area. Hecate Bank seems to be, a retention area for productivity and relatively high energy transfer up the food chain to marine birds and mammals. And there's oftentimes, I think of it as one of those locations that's sort of an oasis, where when conditions, it might be a low food production year for the birds, and you don't see many birds elsewhere, but they're still in relatively high abundance at Hecate Bank. One of the species that I study are short-tailed albatrosses that nest in Japan. And we put tracking devices on those birds in Japan, and we have tracked them all the way over to the Oregon coast and to Hecate Bank. The influence of the bank is beyond the spatial extent of the bank itself. We see not only high bird abundance and diversity over the bank and toward the outer edges, but also near shore and then also at times to the south.
If I'm looking for birds, I'll go down to Neptune State Park and then look in that near shore. And if we're lucky, we'll see them on the water. And so, of course, what they'll do is, since they feed on forage fish, and it could be juvenile rockfish, herring or sardines or sand lance, a suite of species in the buffet. There's something happening on the ocean floor that creates this upwelling and diversity that kickstarts the food web. Birds are here consistently. So to me, it's pretty exciting that you can have these specialists from multiple disciplines zeroing in on special areas.
The gardens are fertilized in the ocean by upwelling. So upwelling is one of the characters that's very common for most of the whale species that we study that are migratory and take place along the California, Oregon, Washington coasts. Offshore here, the Hecate Banks has been an important area most years for quite a few animals, and we have a bit of evidence that the same animals are returning year after year. So I think when whales find something that works for them, they continue to exploit that. Productivity can be very, very different all around the world. And here off the Oregon coast, we get upwelling that's advective from winds that bring cold, nutrient-rich water to the surface, gets it into the sunlight, and makes it more productive for the whole food chain from phytoplankton up to whales. And then you have physical features like the banks, Hecate Banks. So those places have special importance because of the assurance of having upwelled water most years.
The biological abundance of Hecate Bank draws an array of species and the scientists who study them. But the area also draws fishing fleets that come to harvest a range of species in the waters near the bank, as well as those areas impacted by the productivity the bank creates.
We live in a really complex world, and this job is basically the same job it was thousands of years ago, using nets, traps, and hooks to catch this great protein for people and bring it back. That simple mission is something that I enjoy. I feel like I could see where I fit into the planet when we're hauling a trap full of fish or crab. It's a good feeling.
We actually work with a number of local fishermen, and that's the spot they go. You know, they sail out of either Newport or the Florence area, and they go right to that region because they know it's highly productive.
Certainly fish like structure, right? And that's a big structure, right? I think it's one of the biggest structures on the offshore structures on the slope in the fishing areas off the west coast. There's a long history of fishing around the bank, on the bank. The mix of species that's available to the fleet is maybe more available here than other available to the fleet. Because really, for the marketplace, you want to have a mix of species.
I look at a marine chart and I usually get excited because I associate so many good experiences from places I see, and certainly these banks are important. They're part of the basis of the richness of this part of the coast. On the east side of the bank, there's a big horseshoe-shaped area fed by the bank and the richness of the bank. And if the crab are in deep water, you're probably going to find quite a few of them just inside the banks. On the west side of the banks, there's a super steep drop-off. So there's kind of a funneling in the depth curve there. So I think sometimes that's the very best part of the coast that I know of to find sable fish.
Fishermen have long recognized that the banks and the shallow areas that they support around them give them a large area to catch fish. A lot of us that have been treated real well by our industries, I guess, feel like we need to either give a little back or protect what's there or fix what isn't somehow, and do what we can to work with research part of the equation to make it more sustainable.
We've done a lot of collaborative research in this lab, and you realize that first, fishermen know how to catch fish a lot better than scientists do, and they know a lot about the environment and all of the complexities of how our coastal systems work. And so it's really a nice, beneficial relationship when we're able to do that collaborative work.
I've worked with UC Santa Cruz, OSU, NOAA, the state of Oregon, and it's something that I like to be involved in. It's great catching millions of pounds of wonderful wild protein, but I want to also contribute to the knowledge base in some small way.
And I think it's just important that the fishermen and the coastal community and people in general realize how important and productive this bank is to not only the fishing community, but just to the productivity of the Oregon coastal area in general.
While modern fishermen, scientists, birders, and naturalists are drawn to Hecate Bank and the surrounding areas enhanced by its productivity, we also know that the very first humans in the Americas were likely drawn to this same area tens of thousands of years ago.
As sea level is lower, and this happens because to make ice the size of Canada, the water budget comes out of the ocean and lowers the world's oceans. But it would have exposed a tremendous amount of coastal landscape that the people that are ancestral to modern Native Americans would have been living out there, undoubtedly, in this place that's the highest resource area concentration on Oregon's coast. One idea that's pretty popular right now in archaeology in North America is that the first peoples to come into the Americas may have walked and boated their way down the coastline of the Pacific. Now, the evidence for that is very difficult to put your hands on because a lot of it is probably offshore. The banks that are out there, Hecate Bank, the Perpetua, Stonewall banks, these are ground fishing areas that are sort of raised rocky promontories out there. During the last glacial period, as sea level was lower, this would have actually been a small mountain range. So it's a chain of mountains that would have run roughly north-south. And on the east side, on the inland side of it, there would have been a large bay. And this bay is larger than San Diego Bay and smaller than San Francisco Bay. So it sets up these really unique environmental aspects of Oregon's coast that we really didn't understand that much until we started to get into the data and put all the maps together. And then as we've begun to do more of our work with the Nautilus and other vessels, we begin to see into the seafloor, and we're now reconstructing what the river systems are like. We can see actual signatures of river channels, and piecing together this past environment has been really important. And a place like the Heceta Bank has really been a focus for our work so far.
Heceta Bank is now one of the most researched areas on the West Coast. And while there's a lot that we know about how it was created and what drives its productivity, there's still more to learn. And in an era of rapid change that includes ocean acidification, hypoxia, dead zones, and climate change, the data collected over decades on this spot is essential to our understanding of a changing ocean.
So one of the reasons we know so much about Heceta Bank is because of oceanography at Oregon State University, getting out there in ships, making measurements. And it's absolutely imperative that we keep that set of measurements going.
These long-term time series provide some of the most important information we have to look at changes in ocean condition, how that impacts not only these natural resources like marine birds, but also the fisheries too.
So the fishing industry, you want to embrace the kind of science that I can give you for planning purposes if nothing else, right? So I think the fishing industry is probably embracing the scientific side probably more than ever.
Scientific ecological knowledge and local ecological knowledge are on a merging path. But the changing climate is a big concern. You know, the lowering pH, acidification, the rising temperatures and associated changes with that. We need to adapt to these changes, and I'm certain that the scientific community can help us do that.
Well, I think our initial research was kind of pioneering research on Heceta. And so that is, as I say, very gratifying to see that this is something that we kind of initiated and it's continuing. And quite frankly, I've lost track of everything that's going on there now. It's an area that's sort of bustling with research.
Oregon is an ocean state, and we all identify with the ocean. It does, amazing things for us, and it absolutely stabilizes our environment. It provides food, it provides recreation. It does a whole number of things for us. We need to keep that going and have that be a healthy marine ecosystem. And by making these measurements, we can see early signs of change. We can also learn areas that are special, and Heceta Bank is definitely a special place.
Most of the life on the planet is under that surface. There's incredible diversity. It's huge, but it's finite, and we need to take care of it. It's a great big garden.
All right, everybody. So hope you enjoyed that film. Such an absolutely beautiful area and fascinating research. For those of you joining us late, we want to remind you that you can send questions now based on some of the things that you've seen already via the live stream, or for our question and answer panel here in a little bit. You're going to go to www.menti.com. That's www.menti.com. You can go via your computer, through the App Store. There's actually a Menti app, Mentimeter app, that you can put on your mobile devices. And you're going to enter in the 6-digit event code 452729. That is 452729. 29. If you're joining us through Facebook Live or YouTube Live, you can also just go ahead and submit questions there, and we will get to as many of the questions as we can. So again, thank you for joining us tonight. All right, so we've had round one of trivia. It is time for round number two, provided by Ocean 11 Marine Club. Let me get that screen share up for you real quick, and let's get to it. So let us know how you did that first round. We had 4 questions. We got 4 more for you. We're going to want to hear back from you how you did. Number 1, what makes Hecate Bank so green? Chlorophyll, kelp forests, chloroform, suspended sediment. Check out those 4 possible answers and record yours now. We'll go over it here in a second. Every year, this city hosts the largest sand sculpting competition in the United States. Is that Cannon Beach, Oregon, Fort Myers, Florida, Newport Beach, California, or Galveston, Texas? Makes me think I'm going to plan my next vacation at one of these locations if that's the case. All right, get your answer, lock it in. Which marine mammal has the thickest coat of fur? A, the polar bear, B, a sea lion, C, a fur seal, or D, the sea otter? All right, get your answers now. All right, you got it? Let's go. According to seafaring tradition, what do you become after you cross the equator on a boat? Do you become a pollywog, B, Magellan, C, shellback, D, blue nose? What do you become after you cross the equator on a boat? All right. So again, grade your own papers. We trust you. Let's see how you did. Chlorophyll. Question number 5. The answer is A, chlorophyll. That's what makes the bank so green. Next one up, Fort Myers, Florida. Be awesome if it was Cannon Beach. Maybe we should look into that. But Fort Myers, Florida, the largest sand sculpting competition in the U.S. Marine mammal that has the thickest coat of fur. That's D, the sea otter. And they're adorable. And the last one, shellback. You are considered a shellback after you cross the equator on a boat. All right, everybody. So I want to thank you for participating in that. We are going to move right on. I want to see right now some folks that are joining us. I want to see some of the answers that come in for how many you got right out of the 8. We're curious. See what kind of smarties we've got here. What kind of science nerds do we have in the room? Go ahead and stick them up on the Facebook channel if you're interested, or stick them on the YouTube channel. I'll give you a couple minutes, and we'll let them, not a couple minutes, a couple seconds. See what you got. So again, how many of those did you get out of 8? We're curious. So while you're doing that, we are going to get into our Q&A part of the presentation. We, again, like to remind you to use the Mentimeter app, submit your questions here, or go ahead and go through YouTube or Facebook. Make sure you're all ready to go. And before we get started, we've got some amazing folks, I would say in the room tonight, but we're all in our own rooms. You got some amazing folks virtually tonight. What we're going to do is I'm going to start off with Jack Barth and do a quick little introduction. And then I would like everybody to kind of go through in the set order that we had and just unmute yourself and go ahead and give an introduction to all the folks watching us virtually tonight. So Jack, go ahead.
Hi there, I'm Jack Barth. I'm a professor of oceanography at the College of Earth, Ocean, and Atmospheric Sciences at Oregon State, and I'm also the executive director of the Marine Studies Initiative.
And I think, Anna, you're up next, so go ahead.
Hi, everyone. My name is Anna Spalding, and I'm an assistant professor of marine and coastal policy in the School of Public Policy at Oregon State. And I am one of the first round of hires for the Marine Studies Initiative.
Waldo.
I'm Waldo Wakefield. I'm a faculty member in the Marine Resource Management program at Oregon State University, and also work over at the coast as part of the Simmers Cooperative Institute, the Cooperative Institute for Marine Resources Studies.
All right, and Bill, let's go ahead and have you. And folks, I'll say real quick, I just screwed up our order. We had a set order, and I totally went out of order. So Bill, go ahead and unmute yourself and introduce yourself to us. There you
Hello?
go, Bill.
Okay. Hello, my name is Bill Piercy. I'm a retired biological oceanography and one of the founding members of the school, the college, actually the Department of Oceanography back in 1960. So, and my main studies have been on marine necton, mostly things like juvenile salmon.
Excellent. Thank you, Bill. And Saskia.
Hi, good evening. My name is Saskia Madlener, and I'm a science documentary producer at Oregon State Productions.
And last but not least, my favorite person in the room, Tom, go for it.
Hey everybody, my name is Tom McCambridge. I'm a third-year undergrad student at Oregon State studying marine biology and chemistry.
Excellent. All right, so this part of the program, we're going to take your submitted questions and get to as many of them as we can in the next half an hour or so. So we got some good time, so make sure those questions are coming in. After the program, the one big thing is make sure that you know that you have the opportunity to submit questions to marinestudies@oregonstate.edu. Again, that's marinestudies@oregonstate.edu. We'll let you know that again at the end, but without further ado, let's kind of get started. So taking a couple from the YouTube channel, first of all, what proportion of OSU funded research is in ocean studies?
I'll take a shot at that one, Nathan. So it's actually quite a bit. We did a study a number of years ago, looked at all the research grants and all the different principal investigators and graduate students in working on marine things at OSU. And it was at least a third of all the activity going on at OSU. So it's a big proportion.
Excellent. Another question. So one of the questions coming in is around kind of the protection of places like the area that was researched. Anna, maybe to you on this one, or Anna, to you. I'm sorry, I keep saying Anna. Anna, what can we do to protect these amazing and special places in the world?
Yeah, thanks. That's a really great question. So generically, right, as a policy person, there are a suite of tools we can use for conservation. Those tools will range from fisheries management, right? So managing the actual use of fisheries. They can range from closures of areas for what we call de facto MPAs, so areas or protected areas that are not specifically closed for conservation, but they're closed for activities, say like oil rigs or military activities, things like that, right? So it's a range of tools that we can use. Importantly, for areas that are really special and have such important meaning for people and communities, as well as for the folks who use it for their livelihoods, right? Fishermen in particular. It's really important to work with those people who care about those places to come up with the best mix of existing tools to do that. And part of that process involves establishing the vision, right? What is it that you want to do with that area? Do you want to conserve it? Do you want to conserve it to do research? Do you want to conserve it to continue to use those resources? So again, there's a suite of tools, suite of options, and importantly, you really have to work with the folks who use it and care about it in order to come up with the best set of solutions.
Excellent. Thank you. Thank you. One other question that's come up, is OSU involved in the study of how widely spread the effects of micro and nanoplastics infesting the ocean are? So any research around plastics? I'm thinking on that one for a little bit.
Well, let's see, I can speak for some of our researchers at OSU. In fact, there's a brand new study out of our environmental molecular toxicology department looking at plastics exactly. And you mentioned two of the sizes, the bigger plastics, the ones you can see with your eyes, the macroplastics, that's the issue of how they get in and where they go. Our team at OSU is looking at much smaller, the micro and even down to the nano size. And that's when the plastics break down into pieces that could go right into organisms and affect their physiology. And we just don't know enough about that right now. So yes, OSU is involved in plastics research.
Excellent. Good question. Let's see here. Pulling from 3 different channels here. So let's see what else we've got. Ooh, that's a good one. And actually, student perspective wanted on this one. Tom, for you, where do you draw the line between personal responsibilities and societal responsibilities in terms of ocean conservation? That's deep.
All right, yeah, that's a good one. I guess, like, in a way, it's a bit of a blurred line, because, you know, it's the individual actions of each person on their own that's going to make up the overall effect that we have on the ocean and the environment in general. But at the same time, I think it's important that we pay attention to what regulations are being put in place, like we were talking about earlier, because at some point, society needs to step in and give regulations to individuals and businesses, of course. So yeah, it's a bit of a blurred line, and it's important that we just pay attention to both on our own accord.
Excellent. Okay, excellent. Looking through here. Oh, good question. So the Hecate Banks, are they a marine reserve? Kind of what's their classification? Are they a reserve?
Yes, I could take that one. Let me raise my hand here. Sorry about that.
No, you go for it. Waldo, go for it.
So the Hecate Bank and a lot of, well, many of the rocky banks along the West Coast were put into a conservation status as groundfish habitat conservation areas and were closed to bottom trawling back in 2006 after quite a significant assessment of what we know about these areas and about the habitats and the organisms, the communities. And then that process was reevaluated over about a 10-year period, and adjustments were made to these closed areas to trawling and kind of refining it. And a lot of new information became available that was all evaluated over this kind of 10-year analysis. And that was, and Hecate Bank is one of these sort of significant areas that are closed, the rocky part of the bank that are closed to bottom trawling. So that's one form of protection. And then just in general, the fisheries management and the way it operates along the West Coast provides another level of protection, just in general, because the fish communities, fish populations, and other aspects of ocean health are being monitored continuously by a large number of people at the federal government and the state government, scientists, and as well as their partners in the university environment, and so all working together. So there's a lot of information that's being collected continuously about ocean health, and that provides another kind of perspective and input to the protections through management, through fishery management regulations that are sort of separate. They're not separate, but they're kind of on top of what I just mentioned about these very specific spatial closures.
And actually, Waldo, if I can just continue, just because I've got a related question. You talked about federal government and state government being part of oversight of this area. And I don't know much about this, but the NOAA fisheries versus ODFW, what does that relationship look like, and kind of what's the management responsibility look like for that area? So the federal government has fisheries management for the West Coast in federal waters, so in the U.S. EEZ, from the state waters out to the 200 nautical mile limit for the economic zones, the exclusive economic zone. But there is a division between state fisheries and federal fisheries. So in Oregon, for example, there's a whole list of state managed fisheries, which includes things like Dungeness crab and ocean shrimp and some species like that. And fisheries such as those, and then the federal fisheries management applies to a large group of the ground fish, the bottom dwelling fish like flatfishes and
lingcod and rockfishes, for example. And then there's even international treaties that are also involved in the management in some of our fisheries, with our whiting fishery along the west coast, including, that extends up into Canada, and also for halibut. That's another international managed fishery between Canada and the U.S. So there, and all of those, that management, a lot of it and most of it actually gets viewed and analyzed and negotiated through a Pacific Fishery Management Council, which is a fishery council for the U.S. West Coast that involves the federal government, the state government, and then all the constituents, the fishing industry, the fish processors, the fishermen, the environmental organizations, the NGOs participate in the process. So there's this really amazing sort of clearinghouse for information about our fisheries along the West Coast that brings all these people together 5 times a year for about a week. And in fact, that management council meeting is the next one will be next week. Of course, this one's going to be virtual, but normally all these people get together, hundreds of people get together for a little bit over a week, someplace up and down the West Coast, and to look at all the scientific information and evaluate all the management strategies that are in place.
Excellent. All right, Waldo, thank you very much. Another one, production question, maybe a future filmmaker themselves. Saskia, I think this one's going to go to you. How much film was taken in the production of this film? And the second question they had to that is kind of like conveying scientific information to people. It seems like it'd be really tough. So kind of a 2-part question. How do you do that effectively? And then for a film like what we just saw with the Hecate Bank film, how much film was actually taken in that?
So I can't answer specifically to the Hecate Bank documentary, but in general, you only use about 5 to 10% of the footage that you shoot. So you shoot hours and hours. It's not like collecting and analyzing data in science, but although in that case you use all the data, but in this case, especially in the Hecate Banks film, we pulled from different sources. So, we're getting ROV footage. There's lots of graphics that we used. We used some archival imagery of Bill Piercy, some photos of him. Not all of that was shot specifically for that film. So we have a repertoire of 15 years of footage that we've compiled over the time of Oregon State Productions that we can sort of pull from, and that we pull from for all kinds of projects, especially for marine studies. And then for conveying science information, so like in that film, we rely heavily on animations to set the place, the stage, to describe a natural phenomenon like chlorophyll, or you saw that shovel effect of the seduction zone. All those kinds of graphic representations of a natural phenomenon is really useful for us. We even pointed to a scientific graph, which I tend not to do, but you can simplify those graphs. And then what I find to be most effective is really hearing from the scientists themselves and what drives them, and that kind of hooks the viewer. It's this emotional hook, and then you're more likely to listen to what they have to say that's more complex. Mm-hmm. So we kind of do this thing that we call humanize science. Scientists aren't just these siloed ivory tower experts that you can't access. They're actually human beings who care and have drive. And that's really what we like to do in our films often, is to humanize the science.
Awesome. Thank you. The next question, I think this is probably going to be Anna. We're getting Anna. Anna. Oh my gosh, I did it again. Anna, goodness gracious. Anna, to you, around kind of what we can do in that sense of place piece. I'm getting questions on how global warming is potentially impacting the area, sustainable fishing and those practices, all these different things that I guess would view as human controlled things that we can do for the area. What sort of an impact is this having on the area currently? And I guess anything in the work that you do related to that might help answer some of these questions for the users.
That's a really great question. The Hecate Bank video, this is a great two videos to sort of illustrate what a lot of us in my field call the coupled natural human system. So we're looking at a system that is sort of it's this feedback between human activities or human actions and how they affect the environment, and in turn then how that environment comes back and affects people. Climate change, global warming, all of these are great examples of classic coupled natural human systems problems in the sense that it's very clear where how that feedback is happening. An example, two examples, I guess, of the work that I'm doing in that respect. One would be more graduate student work. So I'm part of it was a grant that OSU was working on. It's called the National Research Traineeship. And we had some really great work where a group of students, 4 students actually got together to try to understand the role of the ecological, the social, and policy aspects of how all that data informed the outcomes of marine reserves here in Oregon. So that's an excellent example of how you really weave in these different types of data together, or questions, the human and the social and the natural, to try to understand one of those systems. Another example that I think is really important, and obviously you'll notice my interest in communities and really focusing on what the people along, what coastal communities care about, is specifically looking at their adaptive capacity. So as the environment changes, how are these communities adapting? What kinds of strategies are they using to try to adapt? And then the further point to that would be then how can we develop policies that specifically address those adaptation strategies, right? Right now, we sort of know that we come up with a policy to address, say, ocean acidification, but do we know specifically that policy is going to help the strategies that folks use to adapt, right? And strategies might include diversifying their income, leaving the industry altogether. It might involve, and by diversifying income, I mean, engaging in other activities, connecting with scientists. So it's a range of actions that folks do to adapt, and to be able to develop policies that specifically address those is something that we're hoping to engage with in a grant that we recently received from NOAA, actually.
That's awesome. That's fantastic. Jack, go for it.
Well, I just wanted to maybe pose that same question over to Bill, since he's been associated working on the bank for 50, 60 years. Bill, just your sense of place and your thoughts about the bank.
Bill, we got to unmute you. Hang tight real quick. There we go, Bill. We got you now. Go for it.
Go ahead, Bill.
Okay. Well, I'm not on the full screen, so I don't know what's going on here. Anyhow, it's a unique place in many respects, but as you saw in the film, it's the hotspot for biological productivity. And as I said, it's the largest rocky offshore bank along the whole West Coast. And the other thing I think is very interesting, it's far enough offshore right at the edge of the continental shelf. So a lot of productivity comes not just from the coastal system, but from the oceanic system. Reef houses and lanternfishes and things like that right off the bank, that we know that rockfish feed on those things. So it's a very unique situation. And it's a place I think that we should monitor more closely, and to look at changes over time, long-term changes over time, see how this is going to affect the fisheries and eventually the fishermen, perhaps, in species changes in composition and abundance. And so it's a very unique spot that I think should get more attention. We need to do some long-term monitoring there and get resources together if we can. Hopefully Jack can do this in the future. And so we can do more intense monitoring. And we even talked about instrumenting on top of that bank with real-time information that would be sent back to the Marine Science Center. It'd be great for students and things like that to work on. So it has a lot of potential, and hopefully that can be realized in the future.
Awesome. And actually, Bill, I'm going to keep you on there because the next question I have is literally, subs are awesome. What was it like to be in the sub?
Well, it's a very thrilling experience. When you first go down on the top of Hecate Bank, it's a very rocky area, big pinnacles, things like that. one of the first things you see is a lot of these big, huge marine invertebrates, crinoids and sponges and brittle stars and things like that that just pop up in large numbers on the rocky bank. And then going down deeper, you see all the fishes, hundreds of little juvenile rockfish, for example, on the bottom, and big other rockfish like yellowtail rockfish swimming around in huge schools. And as I said earlier, one of the first dives that went down in these big school of yellowtail rockfish, maybe 50 to 100, thought the sub was their mother fish. And they circle around this sub, round and around and go and just looking at us, and then you can just 5 or 10 feet away, some of them. So that's really, really a thrill. And the diversity of the fishes you see down there, especially big rockfishes and other things, and how the species composition of these fishes changes going from the rocky upper part of the bank down the slope into deeper water. We start to see halibut and things like that. So it was an extremely thrilling experience, and you're supposed to be down there for about a half an hour in the dives, and it seems like that half an hour went in 5 minutes. The other thing that was the most frightening thing that happened, fire on the Mermaid. One of the vessels we were down there initially had an electrical fire in the ship, in the Mermaid, underwater. And we were scared to death on the support ship. We didn't know what's happening. But they came up and everybody was okay. But it was a very frightening experience. And hopefully things like that don't happen very often.
All right. Thank you very much, Bill. Tom, actually back to you. As an undergraduate student, what sort of research opportunities have you either directly worked in or could be available for folks that are interested in marine studies as an undergrad?
Yeah, definitely. That's a great question. It's really, open to students if you want to do it. It's really just about your own motivation, and I mean, a little bit luck of the draw, just finding a researcher who's in need of an undergraduate student. But I was pretty fortunate to have been able to help in Dr. Sarah Henkel's benthic ecology lab freshman year, and continued to work currently on and off writing a paper. Sorry, Dr. Henkel. Yeah, it's really just up to your own motivation, a little bit luck of the draw, but if you keep at it, keep looking for labs, there's plenty of work to go around for everybody. So, yeah.
Excellent, thank you. Another question, and you each might be able to answer a part of this, but great question by Susan on YouTube. What sorts of plans does MSI have to engage in the broader impacts around the bank, especially activities that can engage our youth? And I'm gonna interpret that as maybe kind of a K-12 education piece. Is what sort of things are MSI doing to get students involved in a lot of the things you all have been talking about?
I'll say a little bit, but this would be great to kind of go around the panel. First of all, out at the coast at our Newport, Oregon Marine Center, the Hatfield Marine Science Center, there's a big interest in K through 12 education, both through the visitor center where there's on-site displays and that sort of thing, but also a network up and down the coast of educators in the marine sciences. Just recently, they completed, working with a community down in Port Orford, the middle schools, talking about things like ocean acidification. So I think what we're looking for is how do we take the research that Tom, and as a young researcher, or Bill, who's been working a while at it, how do we bring that into the classroom in a way that the teachers can make use of? A lot of the other topic we might want to touch on is something called citizen science. Could be from school kids all the way up to adults that are interested in helping out. And I'll just kick it out to others on the panel. They'd like to comment.
Let's go. Anna, go for it.
That's a really great question. And I'm kind of going to jump on the previous question as well, and just sort of give a little shout out to the human dimension of marine places, right? So the social science aspects as well. So those of, whether it's K through 12, so although clearly I'm not doing such a good job of communicating what the social science is, my kids still seem to think I'm a marine biologist. Although I tell them that I study people, they're like, oh, that's boring. but I find that it's so exciting to me. I just find it so enthralling to really understand people, their relationship to the ocean, right? If you're a fisherman, what you do, why you do, what's your passion around it, how can we help you continue your actions in a sustainable way? If it's an effort to conservation, same thing, right? Thinking about that mix of tools that I had talked about earlier. And I think MSI provides that opportunity. I think citizen science is a great way to engage, but also, especially through hopefully a new undergraduate degree or just experiences with my, whether it's taking my classes or classes that colleagues in the College of Liberal Arts are designing around the human dimension of the marine environment. And that can range from policy, from fisheries management, to environmental social justice, which is critical to our current times, and all sorts of different elements of the arts and humanities and social sciences that really enable students to get stuck in with issues around the marine environment if they're not biological or physical oceanography inclined.
Yeah, I think that's, if anything else that I learned in going to college was that teams require a very diverse level of expertise, personalities, work styles, strengths. So I think that's really neat when you start learning about other opportunities within fields that might not necessarily be the quote unquote traditional role that someone might have. So thank you, that's great. Anybody else want to chime in on that question? Give everybody a couple seconds. Oh, Bill, hold on real quick. Let's get you unmuted. Looks like Bill's got something for that one. There we go.
Okay. Well, on all the dives we made, maybe about 50 of them, the recordings on these. We had video recordings of what we saw, fishes, things like that. And a lot of ROVs later on that, the remote underwater vehicle, had the same thing. So there's a wealth of information on tapes and on electronic devices for students to look at, for example. They'd be great studies for looking at changes in distribution with depth or things like that. And so there's a lot of opportunities with what is already there. And in the future, if we do more of this, I think there'd be a lot of interesting stuff that people could do with information on ROV dives and things like that. Waldo might want to chime in this too, but there's a lot of data there that had not been thoroughly analyzed.
Yeah, Waldo, do you want to chime in at all on that?
Sure. What Bill touched on with video footage that we have is a real blessing and a curse. It takes an enormous amount of time to extract information from video footage. And there are beginnings of efforts that more and more to try to automate that and use automated target recognition and neural nets and things like that to extract information from videos. But we have a long ways to go for that, and a lot of that just kind of picks the cream off the top. But there's a lot of substantial information, like Bill was alluding to, that could be extracted from that type of archive video footage. I mean, we have rooms full of it at Oregon State University and at fisheries labs around the country. And so I applaud that. I know at the Monterey Bay Aquarium Research Institute, they've done exactly what Bill's describing, where somebody they've actually gone through and they picked information off of some of the videotapes, and it gives you sort of a segue to get into it. And it gives people the opportunity to, again, just take advantage of all this information that's kind of hidden, if you will, in all these rooms full of videotapes. There is a problem actually that we have where we have all this footage that was recorded 5, 10, 15, 20, 30 years ago sitting on video media that isn't necessarily stable forever. And so I actually think there's a bit of a crisis to try to make sure to rescue some of this information so it's not lost. There's actually an example of that for Hecatebank, where some of the original data files for the project that Bill was involved in was some of the magnetic disk media was starting to degrade. And there was a graduate student, a master's student at OSU, who actually went through and kind of rescued all this information and was able to sort of bring it into a stable format and then actually published it. And so it was kind of a really neat example of doing that type of thing.
No, that's a great example. Great example. Next question I have to laugh at because literally I lived this question. The question is, what advice would you give to a high school student from Indiana, shout out to Indiana, who was interested in pursuing marine biology? Clearly, Indiana is not really close to the ocean or a ocean. Anybody want to take that one?
Tom, you got to take that.
Yeah, I'll go for it. Yeah, I'd say there's not much different coming from Indiana than there would be coming from a beach town, honestly. If you just come in, make it clear that you're here because you love the ocean, you want to help, you want to learn as much as possible, and just be ready to do the work. You have all the tools to be successful, I'd say. And, because everyone is kind of joined together by their common love of the ocean. So if you love the ocean, you fit right in.
Yeah, and I'm just gonna put something out there, just kind of tooting Oregon State University's horn. We have a lot of opportunities for undergraduate engagement, like we've talked a little bit about tonight, through research or whatever it might be. So I think even if you didn't have, growing up at 7 years old on the beach every day, you've got those opportunities to engage with faculty and grad students and other undergraduates in a lot of really amazing ways. So I'll say that if you have the passion for it, go for it. Kind of having said that, so we're getting really close on time. One question that came through, we talked a little bit about state and federal regulations and oversight around that area. What does it look like working with some of our international partners in the Pacific, and in what ways have we engaged them? Maybe even outside, I think Waldo was talking about some different work groups or different conferences that you may speak with. What are some international partners that we work with in this area? We'll go.
Well, I felt like I should volunteer Jack.
Oh.
Yeah, Jack, go ahead. You probably have better grasp. I have some different areas, but you go ahead.
I mean, I was thinking of the Pisces organization, Jack.
Yeah. Yeah, and Waldo, you mentioned the Halibut Commission and, of course, the salmon that travel across our international boundaries. But we do have the North Pacific Marine Science Organization, which goes by Pisces, even though that's not the right acronym. It's about 25 years old. It's the 6 countries ringing the North Pacific, and we meet at least once a year, if not a couple times, to talk about all things marine, including the human dimensions, some of the pollutant issues, marine plastics, migratory birds, just about any topic you can think of that the ocean touches on. And so that exchange between the countries is just phenomenal. And to me, it's just remarkable. You go around that, I showed you the globe when we started, that huge North Pacific. There's only 6 countries that that span that whole thing. The US, the Canada, Russia, Korea, China, and Japan. And each representatives from each of those countries get together regularly to talk about how our systems work. So I've talked to my physical oceanography colleagues about banks and canyons off the Russian coast, where the physics is kind of like Hecate Bank. So very useful to compare notes.
Awesome. Excellent. And then we'll go final question. And I'm thinking maybe Saskia on this one a little bit, or Anna. Question is OSU working with any of the local tribes to explore lore or place stories that can provide insights into the past use of the area or other rich cultural traditions in the area?
Sure, I can respond to that a little bit. Well, not specific to marine studies quite yet, not in my experience, but at Oregon State, certainly we partner as filmmakers with the tribal climate camps. And they provide training to different tribes around the nation on how to design and implement climate action plans, for example. And they very much inform each other on their sense of place and knowledge of specific areas, from Alaska to the Pacific Northwest, and then East Coast, and then from to Florida to all over. And so we've worked with them to train them, and they train us too. It's very much an exchange to train them in media production, and then we're trained in storytelling. And we're partnering with them. Hopefully we get to go to the climate camp this summer, this fall. Yeah, that's about it. But so OSU, especially we're trying to partner more and more with local tribes and then tribes nationwide.
Excellent. All right. Well, everybody, just again, thank you so much for participating. We do have a couple of the things to close out the evening, but Jack, I want to give you this opportunity to kind of close us out from your perspective.
I just want to thank all of you out there for joining us for the evening. It's really a great World Ocean Day to focus on, the ocean that's so important to the health of our planet. And I want to thank all the panelists. Thank you. We're never quite sure what questions we'll get, but we managed to find some fun in that. I want to thank all the OSU marine programs and all the colleges out to the coast, up and down the coast. Thanks for all your help. And then to the help with actually making this happen. So I want to shout out to Shelley Sines and Nick Houtman and Virginia Nayland for helping on our end. And of course to Nathan and his great team. So thank you very much.
All right. Well, excellent. Well, as promised, we are going to finish up